Welcome to aminacademy.com. In Aluminium Bird, let us discuss about the main body construction and fuselage of an aircraft. Both aircraft and spacecraft must balance a structural strength and lightness, typically utilizing monocoque or semi-monocoque structure. The core design principle for all flight vehicles is to minimize weight and while maintaining adequate strength to support payload capacity, fuel efficiency, durability, and overall performance. Engineers must carefully select lightweight materials and optimize structural framework to withstand the stress of flight, whether in Earth's atmosphere or space. Flight vehicles are constructed from multiple components, component assembly and sub-assemblies, each serving a specific function but requiring seamless integration to form a fully operated system. Achieving this integration in a complex challenge requiring engineers to consider structural integrity, aerodynamics, propulsion system, avionics, and safety features in a cohesive design. This demands multidisciplinary expertise and expensive extensive experiences, as even minor influences in design integration can impact performance, reliability, and maintainability. Whether for airplanes or spacecraft, effective components integration is essential to ensuring safe and efficient operation. Now let us discuss further about the main body construction of the flight, that is fuselage. The main body of an aeroplane called fuselage is a long hollow structure that supports the weights, tail assembly, and other components. It is designed to provide a space for the crew, passengers, and cargo, and to be aerodynamically efficient. Fuselage constructions can be either truss type of monocoque or semi-monocoque design. Fuselage construction, truss type. This older design uses the framework of beam and struts, often made of wood or steel, with a covering of fabric or metal. Monocoque, semi-monocoque. Modern aircraft typically use this construction, while the skin of the fuselage is an integral part of the structure, describing loads across the entire surface. Material. Common material include aluminium, magnesium, titanium and their alloys, as well as composite materials like carbon fiber. Aircraft bodies are primarily constructed from aluminium alloys and composite materials like carbon fiber reinforced polymers. Aluminium alloys are lightweight, strong and corrosion resistant, making them a suitable choice for many structural components. Composite materials, on the other hand, offer a higher strength to weight ratio and are becoming increasingly popular for structural parts like wings and fuselage. Duraluminum. Duralumin, an aluminium alloy, is a key material used in aircraft construction, especially for the body of aeroplane. It is a lightweight, strong and corrosion resistant material, making it suitable for various parts including the fuselage and wings. Wing, aerodynamically shaped structure that generates lift to overcome the aircraft weight. Empennage includes the horizontal and vertical stabilizers which provide stability, flight control surfaces, ailerons, elevators and rudder which controls the aircraft movement. Landing gear allows the aircraft to move on a ground. Air fuel tank. This is a typical air fuel tank for the aeroplane. Aircraft fuel tank are typically located in the wing, often integrated into the wing structure itself. This placement minimizes stress on the wings during flight and helps with the weight distribution. Fuel tanks can also be found in the fuselage or tail depending on the aircraft design. Wings. The most large airplanes store fuel in their wings, often within the wing structure itself, integral tanks. This reduces stress on the wings by placing the weight close to the source of the lift. Fuselage. Some aircraft have tanks in the fuselage, often the center tank, or near the tail trim tank. Fuel tanks capacity. For example, Boeing 747-8, approximately 63,034 US gallons. It's near about 238,610 liters. Airbus 380, approximately gallons is 84,472 US gallons, that is equivalent to 3,23,546 liters. Boeing 737-800, around 6,875 US gallons. Fuel consumption. A Boeing 747, for instance, can consume roughly 4 liters, approximately 1 gallon of fuel per second. This very high fuel consumption, that is 4 liters per second. This translates to near about 240 liters per minute and 14,400 liters per hour. Fuel consumption is influenced by factors like aircraft type, flight distance, weather, and payload. Boeing 747. A Boeing 747 can burn up to 4 liters, that is about 1 gallon of fuel per every second. Most airplane uses Jet A1, that is a type of kerosene-based fuel, as their primary fuel source. This fuel is widely used in turbine engine aircraft, including commercial jets and military aircraft. Another type of the jet fuel, that is Jet A, is also used, particularly in the United States, and both are interchangeable. A third type, Jet B, is a white cut kerosene or gasoline blend, less commonly used except in very cold climates. White petrol is known as aviation gasoline, avgas, is a highly refined petroleum product. It is a fraction of kerosene, meaning it is distilled from crude oil. Landing gear. The landing gear of an aircraft is the system of wheels, struts, and other components that allows an aircraft to safely land, taxi, on takeoff. It's essentially the undercarriage of the plane. This system includes the main landing gear, usually located under the wings or fuselage, and the nose gear or tail gear in some designs. So far we discussed about the body construction of an aeroplane. In further details we'll continue in next videos. We have done. Please subscribe our YouTube channel.